Today we will talk about trigonometric functions of any angle. This is section 4.4 in your textbook. The essential questions are, what are the definitions of trigonometric functions of any angle, and what are their signs, and what are reference angles, and how do you use them to evaluate trigonometric functions? So let's start off and talk about how we represent angles. So if we're talking about the xy coordinate system, we have a y-axis, we have an x-axis. Standard position for angles begins at the positive x-axis and goes counterclockwise for positive angles. So it goes in this direction, all right? So we have first quadrant, second quadrant, third quadrant, fourth quadrant. Now, if we, this is the initial side of the angle, this line here, okay, this represents the terminal side of the angle, all right? And if we were to pick a point on that terminal side, that point would have coordinates x and y, and this length here would have a distance equal to r, okay? And the coordinates of this would be simply x, comma, y. All right, now, if we want to know what the trig functions are based upon that, and what we know about the unit circle, we obviously could take and form a right angle here, or a right triangle rather, and there we go. So if we make this a right triangle, okay, we could use right triangle trigonometry or what we know about the unit circle to come up with definitions for the different trig functions. So specifically, and we'll call this angle theta in all cases, so this is going to be angle theta, and that is this angle right here. All right, so if that's the case, the sine of theta is going to equal y over r. With the unit circle, remember, r was simply equal to 1, so therefore it became equal to just y. But this is, in this case, r is not equal to 1, so sine is equal to y over r. Cosine, similarly, will be equal to x over r. And tangent, therefore, would be equal to y over x. Now, once you have these three basic trig functions, you can get the other three because you know they're reciprocals. So the cosecant of angle theta will simply equal r over y. And the secant of angle theta will equal r over x. And lastly, the cotangent of angle theta would equal x over y. So here we have definitions for all the trig functions of any angle. Now, if we use these definitions and we go back to our general case of a y-axis and an x-axis, we know we've got four quadrants here. We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now obviously, since x can be positive or negative, depending which quadrant you're in, and the same can be true of y, then the signs of these trig functions are going to vary depending on which quadrant you're in, okay? So if we're in the first quadrant here, all of them are going to be positive, because in the first quadrant, x is positive and y is positive. So all the trig functions will be positive in the first quadrant. Now, the second quadrant, however, sine and cosecant will remain positive because the y value is positive. However, the x value is negative. So the only ones that are positive here are going to be sine in the second quadrant, and cosine, tangent, secant, and cotangent are all going to be negative. Now if we go down to quadrant 3, both x and y are negative. So sine and cosine and secant and cosecant are all going to be negative. But tangent and cotangent, since they're x over y and y over x, are going to be positive. And then lastly, we've got quadrant 4, where x is positive and y is negative. In this case, sine and cosecant, tangent and cotangent are going to be negative, but cosine and secant will be positive. So how can we remember all of this without having to go through and analyze it? Well, there is a saying which helps us to remember this. Now this saying is, all students take calculus, all right? So if you start in quadrant 1, the A means that all the trig functions are positive. If you go to quadrant 2, notice we've got an S here, all right? We started off with A, meaning all the trig functions were positive in quadrant 1. Quadrant 2, we've got an S, which means that the sine and its reciprocal, the cosecant, are positive in quadrant 2. Then if we go to quadrant 3, we've got a T, which means tangent and its reciprocal, cotangent, are positive in quadrant 3. And then lastly, we go to quadrant 4, and cosine and its reciprocal, secant, are positive in quadrant 4. So if you can remember this saying, you know in which quadrant the trig function is positive and in which quadrant it's negative. Now once our angles get into the second quadrant, in other words when they're greater than 90 degrees, it gets a little bit confusing and a little bit more difficult to figure out, or to use a table, for example, to figure out what the trig functions are. And this is where it comes in real handy to use reference angles. So what exactly is a reference angle? A reference angle is the positive acute angle formed by the terminal side of the angle and the x-axis. Okay, let me repeat. It's the positive acute angle formed by the terminal side of the angle and its x-axis. For example, let's assume that we've got an angle in, if you're in the first quadrant, it's pretty obvious what your reference angle is. It's simply equal to that angle. But say we're in the second quadrant, okay? We've got a y-axis and an x-axis, and our angle is over here. Okay, there's our angle. It's in the second quadrant. It's greater than 90 degrees. The reference angle is going to be this angle here, okay? It's the angle formed by the terminal side and the x-axis. It's the acute angle formed by the terminal side and the x-axis. It's not the obtuse angle, it's the acute angle, all right? So how do we find the reference angle? All right, so let's go back here to assuming we have, here's our horizontal axis, is our vertical axis. All right. Reference angle in the first quadrant is pretty obvious. It's equal to the angle, okay? If you're in the second quadrant, how do you find the reference angle? Well, the reference angle is simply equal to 180 minus the angle theta, okay? And remember, this is the angle theta right here, okay? So in the second quadrant, it's greater than 90 degrees, but it's less than 180. So the reference angle is simply equal to 180 minus theta. Third quadrant, if the angle is between 180 and 270, how do you determine it? Well, in this case, you take the angle, whatever the angle is, and you subtract 180 from that, and that'll give you the reference angle. Okay? So obviously we're down here in the third quadrant. Our angle is going to be somewhat like from here all the way over to here. It's going to be greater than 180, but less than 270. So we simply take 180 away from it, and that gives you your reference angle. Lastly, if we're in the fourth quadrant, we're down here. The reference angle can be calculated by saying 360, which is the full circle, minus the particular angle which puts you down into the fourth quadrant. Okay? So those are the definitions of how you find the reference angle. As I said again, in the first quadrant, it's simply equal to the angle. Second quadrant, it's 180 minus theta. Third quadrant, it's the angle minus 180. And then fourth quadrant, it's 360 minus the angle. So if you're going to find the trig function of any particular angle and you want to use the reference angle, go ahead and use the reference angle, but then you have to remember what the sign is going to be. So you must go back to understanding which quadrant you're in, okay? So you need to know the reference angle, but you also need to know the quadrant you're in to get the complete or correct answer for the trig function in terms of what is the sign and what is the actual value. So let's look at an example here to understand how we're doing this. Let's say I want to know the tangent of 120 degrees, okay? Tangent of 120. Well, first of all, 120 degrees puts me in the second quadrant, right? So the reference angle for that is going to be 180 minus 120. So the reference angle is going to be 60 degrees, okay? So the reference angle in this case will be 60 degrees. Now, we are in the second quadrant. So is tangent positive or negative in the second quadrant? If you remember how we discussed it in the previously, the tangent in the second quadrant is negative. So therefore, the tangent of 120 degrees using the reference angle is equal to minus the tangent of 60 degrees, okay? So this is how we can use the reference angle and knowing what quadrant we're in, determining whether it's positive or negative. All right, now what I'd like you to do is, using the reference angle, determine the answer for the sine of 300 degrees and post your answer in the drop box. Not only do I want the answer for the sine of 300 degrees, but I also want to know is what was the reference angle and what is the sine of that answer. Okay? Thank you.